And I guess we can proceed with Shailesh Gohel also. Shailesh is working as a tester at Litera, and Rishil is working as principal performance engineer at Litera Systems. They would be conducting a lab session on performance test engineering, beyond record and playback. To know more about them and to see their video interview, uh, please check the links given below. Sir, over to you. Now I'll stop sharing and you please continue.
Okay.
Okay, sir.
Okay, so is my screen visible and am I audible?
Yes, sir. Yes, sir. Your screen is
Okay.
visible and you are also audible.
Okay, perfect. Okay, so hello everyone. Most welcome and a very good evening and good morning. So wherever you are from, and thank you so much first of all for joining. And I would like to send my warm regards to Agile Testing Alliance, everyone at ATA for conducting this amazing global testing retreat. My name is Rishil Bhatt, and I am lead performance engineer at Litera Microsystems. So me, along with my partner, Mr. Shailesh Gohel, we were going to present the session on performance test engineering record and beyond record and playback. But due to some unavoidable circumstances, Shailesh is not going to join. So I'll be your sole presenter. So before we start into the session, let's look at the things that we are going to discuss today. Okay, so these are the topics we will cover today. We'll start with what, why, and when of performance testing. Then we will talk about non-functional requirement in brief and about its importance. We will look at the mistakes we usually make when we are doing the enterprise level performance testing and how we can avoid them. So this first three slides will be about the theoretical stuff. After that, we have two demo planned. The first demo is all about Apache JMeter, how we can record the script in Apache JMeter, then how we can execute it in GUI and non-GUI mode, and how we can generate the HTML reports, then and how we can analyze those reports. So this will be the demo 1. So in demo 2, what we have planned is the demo of the application performance monitoring tool. And today we are going to discuss about Prometheus, how we can connect Prometheus to see the real-time server statistics like CPU, memory, disk, and all the sizing related stats. So that entire setup we are going to look at, and at the end we will talk about the architecture of performance test engineering framework. See, for automation there are n number of frameworks available, so every now and then a new framework comes, but for performance testing there are not so much there is no so much framework available. But yeah, we can build the framework on our own, and that's what we are going to discuss today. Now let's get started. Okay, performance testing. So basically performance testing, it is a journey to make sure that whatever the software product you are building, it never crashes, it never slows down, and it never performs weirdly under any circumstances. So that is what the performance testing is all about. Now, to understand the why do we need to do performance testing? Imagine you are a hardcore football fan and you are watching the most anticipated match in this FIFA World Cup, where the team you are supporting is playing. The match is at a very crucial stage. A penalty kick is given, and while you are watching, the streaming application on which you are watching, it crashes down and or it goes slow and you miss that particular moment. Now you can imagine how you would feel about that, right? So that is not something very much pleasant. And to make sure you do not feel that, that streaming provider has to make sure that all the millions of watchers must have the seamless experience. There can be n number of examples. If we talk about current time, around 70% of the world business is online. So if we are not doing the performance testing, or if we are not doing it correctly, then there is a high possibility that uh, we can go ahead with the business loss, right? So it is that much important. Around 3 or 4 years back, the industry standard average response time was around 5 to 7 seconds, but right now it is around 2 to 3 seconds. So there is a high possibility that after waiting 3 to 4 seconds, your end customer is going to switch to your competitor's website. So that is how crucial it is, and that is why performance testing must be included in SDLC. And talking about when should we do it, so this is where most of the organizations do the mistake. They start with doing the performance testing as a formality whenever the product is release ready. Now imagine if you find a bottleneck in the core architecture of the application. Now you do not have enough time, capacity, or the budget to restructure your application, right? So that is not something you want to face. That's why the performance testing activity must be started from the first phase of the SDLC, and that is the requirement gathering phase. And that is what we are going to talk about next. That is non-functional requirements. Now there is a list of non-functional requirements, much more than what I have mentioned over here, but these are the non-functional requirements, very important and must be considered before we start with the performance testing. For example, in scope features. See, all the features, all the scenarios, all the functionalities of your application cannot be the candidate for performance testing. If you take the example of Amazon.com, so how many of you go to Amazon and visit contact us page or terms and insurance page, right? So we never go there. So there is no point generating the load on those areas where our end users are not going to come. So that's why we need to identify which are those scenarios, which are those functionalities on which the end users are going to come the most. Those are the performance test candidates. You need to discuss with your product owner, your business analyst, or customer, or whosoever is responsible, right? So you need to identify those features. Next is transactions per second or expected response time. See, whenever we do the manual testing, when we write any test case, so in the test case we write these are the steps and these are the expected results. So in the non-functional testing, the same policy applies. When we do the performance testing with, let's say, 200 concurrent users, but do we have the expected behavior decided that with 200 users, with this many scenarios, the expected response time should be less than 5 seconds. So this must be decided and this must be documented way before you start with the execution. Expected concurrency. And this is again one of the most important part, that how far do you want to go, right? What is the business requirement for this? Let's say if I'm doing the performance testing of an application who is going to go live within a month, we also need to consider that after 6 months or after 2 years, how much business, how much concurrency it is going to expect. And we need to take that into the consideration today. And we must have that expected concurrency during the requirement gathering phase. Now, types of the performance test. Now there are many different types of performance test. Performance testing is a generalized term. But under performance test, there is a load testing, there is a stress test, endurance test, spike test, and volume test. If you want to check the threshold of your application, you need to do the stress testing. If you want to check for a specific set of users, if I run them for a longer period of time, and if you want to check how your system is behaving, then you need to do the endurance test. If you want to check the sudden increase and decrease of the concurrency, and if you want to check how your load balancers are working, your server instances are working, then you need to do the spike testing. So based on the requirement, what you are supposed to do, what is the purpose of your performance testing, based on that you need to decide the which type of performance test you need to take into the consideration. Next is test data. See, you cannot do the performance testing with live production data. So same as the manual testing, you need to have the test data ready for your execution. Next is the one of the most important point, that is hardware utilization. And this is where many organizations do mistake, like they simply do the execution on either QA server or staging server. Now we know that our QA server and staging servers are not up to the mark. It is not as good as the production environment. So the performance testing must be done on a server which is in compliance with the production environment. Then and only then you will get the realistic results. If your production environment is having RAM of 16 GB and your QA environment is having 2 GB RAM, so there is no point doing load testing on the QA environment, because you are not going to get the realistic results, right? That's why it is very much necessary. Now if you are doing the performance testing, you will be using one of the tool like Apache JMeter or Load Runner. Now these tools will give you the results, it will give you the statistics related to the performance testing. But while the performance testing is going on, you want to check how your servers are behaving, how your servers are performing, what is the CPU, what is the memory consumption, what is the disk, what is input output operation, is there any server level exception or not. So for that, the performance monitoring tool must be configured to your server, and it needs to be monitored while your execution is going on. So these are some of the basic non-functional requirements that we need to understand, and we need to make sure that these requirements are fulfilled. Now, next we have is the mistakes to avoid when we start with the performance testing. Starting without NFR or SLA, it's like you are doing performance testing, but you don't know what you are supposed to do. So it doesn't matter if you do the performance testing or not, because you are not going to serve the purpose, right? So you must have non-functional requirement and SLA in place. Starting performance testing late, we discussed this just now. What happens when we do the performance testing at the later stage of the SDLC? It is not advisable. Now, missing mature workload model. Okay, we just discussed that we can have the in-scope scenarios. Okay, now out of these in-scope scenarios, we cannot like generate the equal load on all the scenarios. That's not how it works in real time. We all access Amazon, but there is no specific set of actions that we perform. I must be searching for some another product, someone else will be searching with another product. I'm going on product detail page, I'm reading the comments, someone else must not be reading the comments. It is like there is no a specific set of actions. Okay, so then that's why we need to decide the workload model. Let's say I'm going to generate 100 concurrent users. So out of 100 concurrent users, I want 10 users on functionality 1, I want 25 users on functionality 2, and that's how, based on the intensity of that functionality and importance of that functionality, we need to divide our virtual users, and that's how we need to do the execution. And this part is missed almost every time. So, and this is a very important stuff. Now, repeated use of hard-coded data. Let's say there is a scenario where I search for the product. Okay, I must be searching with some keyword. Another user must be searching with another keyword. We all do not search with same product, right? So if I'm generating the load of 100 users, I cannot give the same keyword to my all 100 users. It is not a realistic scenario. The purpose of doing performance testing is to first to make it as realistic as possible. So all the hard coded data, whatever it is, input from the end user side must be parameterized, and the test data should not be in repeated mode. Okay. Now the performance testing infrastructure, we discussed this in length, why a proper performance testing infrastructure is necessary. So these are the mistakes we often make when doing the performance testing. We generate the results which are not realistic, and okay, so yeah, these are the mistakes. Now, going forward, we will start with our first demo, where first we will talk about the application that we are going to use for the recording and execution. Then we'll see how we can record the JMeter script with BlazeMeter plugin. Then we will talk about the basic components which are used for a simple load testing in JMeter. Then we will do the execution in non-GUI mode, and we'll see how we can generate the HTML report in JMeter. And then we will do with the report analysis. Okay, so let's get started. Okay, so this is the application. This is open source demo Orange HRMS Live. So this is the application that I'm going to use. So first I will hit on this page. I will log in with valid credentials. I will land on the dashboard page, and I will click on this My Leave button. Okay, and I will log out from the application. So this is the scenario I'm going to record. Now, with JMeter, there are two ways you can do the recording: through JMeter itself, where you need to set the proxy. In JMeter, the same proxy you need to set in the browser. You need to do that connection, and then you need to start the JMeter server. And then whatever action you perform on your browser gets recorded inside your JMeter. That's a complicated way, but BlazeMeter provides an excellent feature. That is a plugin available for Chrome browser. So this is the BlazeMeter plugin. Okay, so I have just given the test plan name. So here you can give the test plan name. You just need to click on this button, start recording. Now you can give the test scenarios or test cases or test label, whatever you call it. Our first test case is the landing page. So I will give it, I will add it as a step. Okay, and I will hit this URL. So it will be recorded under this particular label. Now what we need to do is, next step is we will log in into the application. So I will add one more step over here, login. Now whatever action I will perform, it will be recorded under this particular label. So and login. Okay, so you can see that there are 10 entries captured under this particular label. Okay, now what we need to do is, let's do the logout. Okay, so I will add one more label, logout, add step, and I will click the logout over here. Now my recording is completed, so I will click the stop, and I will again go back to BlazeMeter plugin. Now this JMeter test plan is available for me to download. I can click on this save button. It will give me 3 You need to select this JMX option. So JMX is the format that is supported by JMeter. It is the extension. You click on save button and this JMX file will be downloaded in your machine. Now for this demo, I have already created the test plan, which I'm going to open over here. Okay. So this is the similar JMX file that I have opened. Now we will talk about the basic level components that are required for a simple load testing in JMeter. Okay. Now, okay. So if I'm going too much fast and if you have any query, please let me know. Okay, I'll keep my eye on the meeting chat. So if you are having any confusion and if you want me to repeat anything, please just let me know. I'll do it again. Okay. Now this is the JMeter test plan. Under JMeter test plan, the first thing that we are going to talk about is the thread group. Now thread group is one of the JMeter component where you can configure what kind of test you are going to perform. Over here. Okay, what will be the ramp up period? Okay, now ramp up period is the duration in which all your number of threads will be up and running. So if I'm giving 100 as a thread count and 10 seconds as the ramp up period, and if I start my execution, then within 10 seconds, all my 100 users will start their journey. So that is what the ramp up period is. And the loop count. Third one is the loop count. Loop count is how many iterations do I want to perform for all the threads. So if I'm given 5 over here, and if I have given loop count as 5, then all the 5 users will do the execution 5 times. So that is the loop count. And if you want to run it for a longer period of time, then you can specify the duration here. You can specify the duration in seconds, or you can here you can select infinite. So it will keep on running until you manually stop the execution. Okay, so this is what the thread group is. Next, we are going, you will see there are 3 folders created over here. These are the 3 labels. These are the 3 steps that I have recorded through my BlazeMeter plugin. The first one is the login page. The second, where I'm performing the login, and third, where I'm adding an employee. Okay, so when I perform the login on the browser, if you open the network tab, if you press F12 and if you open the network tab, you will see that these many requests are executed for that particular action. So all those requests are recorded and you can see it in your JMeter test plan. Okay, now let's select the one where we are sending the username and password. Okay, so this is the API. This is the request where we are sending username and password. As you can see that I'm not passing the hard coded username and password over here. I have parameterized it. Now to do the parameterization in JMeter, there is a component called CSV dataset config. You can add it, right click on your test plan, go to config element, and the first option you will see is CSV dataset config. So CSV dataset config is whatever the data that is supposed to be an input from the end user that you can configure in the CSV file. So this is the CSV file. Let me bring that CSV file to the screen. Okay, so this is the CSV file. Now the first row is the variable name. So this is the variable name I have given in my JMeter test plan, the username and password. So if I select this, then dollar in curly braces password, and in the same format username. So when I will start my execution, what it will do is it will read this particular label and it will read its value, and this value will be passed in this particular URL. So along with username and password, I have parameterized 3 more parameters. See, right now we only have one user, right? So that's why I have only one row over here. Let's say you have 100 users, so you can have 100 rows over here, so with different user credentials, right? But that's not what we need right now. So I am having only one taste data row, but whatever the taste data requirement for you, you can configure it in the CSV file. Now, coming back to our JMeter screen, now your web browser manages cookies and cache mechanism by its own, by its internal mechanism. Okay, but JMeter is not your web browser. Here you need to add 2 config elements, HTTP cookie manager and HTTP cache manager. Okay, so these 2 elements will manage and forward your cache and cookies values. For example, session IDs. Okay, so session IDs are stored in your browser cookies, right? And you don't specifically uh, send them, you do not specifically correlate them, but here you need to add the cache manager and cookie manager so that it will use the internal storage of JMeter to store your cache and cookies. So these 2 are must-have elements. You can have the user defined variables. For example, base URL, you can have it over here. You can mention it over here. Let's say I have recorded my script on QA server and now I want to run it on the staging server. So I cannot go to each and every request and change the server name IP over here. So what I have done is I have parameterized it. Okay, and now if I want to run this script on any other server, then I need to change it only in user defined variables. So this is again a very useful component. Now, when we do the execution in JMeter, we want to store the results somewhere, right? So that's why for that purpose in JMeter, we have listeners. So this many listeners are available in JMeter. Today, we are going to talk about view result tree and aggregate report. So I have added view result tree and aggregate report over here. So whatever the statistics JMeter will collect, JMeter will showcase them over here. Okay, so this is the JMeter screen. Now, next, what we are going to talk about is how we can run the JMeter in non-GUI mode. Here, what you need to do is you need to simply click on this green button over here and it will start the execution. But keep in mind that when you are doing the actual performance testing, you cannot do it in the GUI mode because you do not want your JMeter consumption of memory affect your test results. So whenever you are doing the performance test execution from your machine, make sure there is no other application running in your machine and all the memory and all the RAM is at the service of JMeter, which you are going to run in the non-GUI mode. Okay, so I'm not going to run it in GUI mode. Let's see how we can run it in non-GUI. So for that, you need to open the terminal. Okay, now you can execute, you can trigger the JMeter non-GUI mode, but for that you need to go to the JMeter bin folder. So right now I am in my JMeter bin folder and there is a JMeter batch file available, and that's what we trigger to execute the JMeter execution. Okay, now This is the command that we need to fire for the JMeter non-GUI mode execution. Okay, let's go through this command. Now, if you're running it in Windows, then you don't need to give sh over here. But for Mac and Linux, you need to start with sh, then space JMeter, then space -n. -n stands for non-GUI mode, then space, then -t, then space. This is the complete path, end-to-end path of your test plan. So my test plan is under desktop, this folder, and this is the file. This is the JMX file. So we need to give the complete path. Okay. And after that, space and -l. So this is for the log. So this is for the report. And again, you need to give the path and file name .jtl. Now JMeter will prepare the report either in JTL format or CSV format. Okay, so you can give it in the JTL format. Now let me go back to JMeter. Here I have given thread count as, let's not take the execution longer. So thread count as 2 and the loop count as 1. I will save the test plan. I will go over here and I will start the execution. Okay, now while the execution is going on, you can see that uh, while this is running, there is no much thing you can do over here. You are not seeing any fruitful results in your terminal screen, right? So there are active threads to started to, but if there is an error, then what is that particular error? What if you want to check your particular request, how it is performing, what is the response time, what is the throughput, what is the 90th percentile value of any particular request, you cannot see while your execution is going on. So this is one of the disadvantage of running JMeter in non-GUI mode. Our execution is completed. Okay, it took a very less amount of time because we had kept the virtual user as 2. But when your virtual users are 100, when your functional flow is long enough and your loop counts are there, then it can run up to 30 minutes, or sometimes if you're doing the endurance test, then it can go up to 6 hours, more than a day, couple of days. So you cannot just sit back and wait for the execution to end and wait for the results, right? So that's what we are going to see in our next part, in our next demo. But for now, our execution is completed. Now let's see what it has generated. So it has generated this demo1.jtl under this particular location. Okay, now I can browse this demo1.jtl and I can open it over here. Okay, now this is a different demo1.jtl file. Okay, it is telling me there are 52 samples over here. Because we ran it with only 2 users and it was not going to produce this much amount of results. So to explain you this aggregate report, I have already ran it for 50 concurrent users, and this is the aggregate report. This is the JTL file of that particular execution. Okay, now let's understand what this aggregate report is telling us. The first column, this is the label column. So these are the labels you are seeing over here. The same you have under your test plan. So under the login page, you have 2 labels. So these 2 labels are from the login page. These labels are from the perform login scenario, and these are the add employee. Okay, so you will see that over here. Now the samples count. Now what is a samples count? So how many times this particular sample got executed? So that is what the sample count is. I ran it for 52 virtual users. So that's why it is showing us 52 over here. But this does not mean that the concurrency was 52. Your sample can have a 50 count, but it can also mean that the thread count that you had defined under your thread group was 10 and loop count was 5. And that can also produce the sample count as 50. Okay, so just keep that in mind. Now, the average response time. So for all 52 samples, uh, they got executed and they return back with some response time. So the average response time of all 52 samples is what you are seeing over here. Now this value is in milliseconds. So basically this is 0.5 seconds. Okay. Now talking about this 90 percentile, 95 percentile and 99 percentile, and why do we need them? Okay. Now imagine your sample count is 100. Okay. Now out of 100 samples, your 90 samples are responded within 3 to 4 seconds. But there are 10 samples which took response time more than 50 seconds or 60 seconds. So now imagine your average response time is increased at a great level just because of those 10 samples. But when you look at the average response time, you will see that, oh, my application's response time is on a higher side. But on the other hand, the reality is only 3 or 4 requests are responding with so much response time, and that is making the average response time going on the higher side. Okay, so that's when this 90th percentile comes into the picture. Here, what you do is, what JMeter do is it removes the top 10 percentage layer of all your samples, and whatever the next value you get is your 90th percentile value. So you get a more realistic result. Same is for the 95 and 99. In 99, it will remove top 1%, and whatever you get is the 99th percentile value. So here you have the error rate. If any sample, if any request is errored, that you see it over here. So, and this is the throughput. The throughput is basically the capacity of your server to serve any particular request. Here you will not see that much of realistic results. But when you will do the performance testing with the proper testing infrastructure, you will see proper results. Here you see that 7.4 per hour. So per hour, 7.4 requests got served. So if your response time is on the higher side, you will see it is reflected in the throughput. Right? In some requirements, in some cases, you get the requirement to achieve the throughput. You want to achieve this throughput, and that can be, you can get the requirement in that form also. Okay, so this is the aggregate report. Again, this is not the report that you can present to your top management. Okay, so for that, JMeter comes with HTML report. Using the same JTL file in JMeter, you can create the HTML reports. So let's see how we can do that. So for that, you need to open the JMeter. Okay, go to tools and generate HTML report. So here you need to give the path of your JTL file. We have it under this folder. The user.properties file, the path of the user.properties file is, it is at in the JMeter bin folder. Here you will see the user.properties file and the output directory. Output directory, I will keep it under the desktop. This is my output directory and I will generate the report. So now JMeter is generating the HTML report. Okay, the report is created. Let's bring that report to our screen. Okay, so this is what JMeter has created. This is the HTML report. This is the dashboard page. Here you will see the complete aggregate report, whatever you are seeing in your JMeter. If you have errors and all that, that you can see over here. But the beauty of this HTML report is its charts. You get so many different types of charts over here. So this is response time over time chart. So for any particular request, so you see that on the left side, you have average response time in milliseconds, and this is the total time duration. Okay, so this particular request, so this is the perform login request. So this was the journey of this particular request during your execution. Okay, so through this chart, you can easily identify that this particular request add employee, it is at the highest level, and its average response time is around near to 6,000 milliseconds, and that is 6 seconds. So through this report, you can identify, you can pick those requests which are responding with the higher response time. There are other charts as well, response time. There is one chart called response time overview. Here you can see that how many requests having response time less than 500 milliseconds, between 500 milliseconds and 1.5 seconds, and in the third column more than 1.5 seconds. So these are the graphs you can publish in your, when you prepare your end report, and it can help the higher management understand the current applications behavior in terms of performance, right? So this is the HTML report, and I guess we are done with our first demo. Let me bring back. Okay, so I see one question over here. So I'll address all the questions at the end of the session. Okay, now the most interesting part of our session starts. So that is the demo 2. Okay. Okay, now here what we are going to do is, so this is what I have configured. This is the architecture of the automated setup for the performance testing that I have done. So let's first understand all the components that you are seeing over here. The first one on the top, this is my machine where my JMeter is running. Okay, now from my local JMeter, okay, now what I have done is on AWS, I have configured 2 different Linux machines. Okay, in one Linux machine, I am running one web server. Okay, now from my local JMeter, I am generating the load on the first EC2 machine. Okay, now in the second EC2 machine, I'm running Prometheus. Now, what is a Prometheus? Prometheus is the application performance monitoring tool. So it is a live time series application performance monitoring tool. So while I will be generating the load on the first Linux machine, my second Linux machine will grab all the statistics from my first machine and it will store it in the Prometheus. Okay, and now this Prometheus will flush all the data to Grafana. Now, what is Grafana? Grafana is the time series data visualization software. In simple terms, it gives you the dashboard where you can see, sorry, it is the dashboard where you can see what is the current status of the execution live. So that is what we are going to see now. So that is the first journey. That is the first path. Now, in the same execution, when my JMeter is generating the results, it is also capturing the results in form of aggregate report just we saw. Okay, now I don't want to see the aggregate report or the HTML report at the end of the execution. What I want to do is, while the execution is going on, I want to see the live reports. Okay, so for that, what I'm going to use is I'm going to use InfluxDB. Now InfluxDB is a real-time series database. So what JMeter will do is, the moment JMeter will start receiving the response from the server, it will keep on sending the response to my InfluxDB database real time. And this InfluxDB is further connected with the Grafana, same Grafana dashboard, where I can see how my execution from the JMeter's perspective is going on. So you see, you have the complete setup over here. You just need to start the execution. You have two dashboards available with you, two amazingly looking dashboards available. And one dashboard is telling you how your server is behaving, and another dashboard is telling you what are the JMeter results. Okay, now to explain it further, this is the same thing that I just explained. On AWS, I have two Linux machines. So traffic will come from my local JMeter to my first Linux machine, where I have configured a web server. Now, okay, now in order to make Prometheus grab all those statistics from Linux machine, what we need to do is we need to have that bridge, right? So for that, there is a thing called node exporter. Now what node exporter will do is, I have installed node exporter on my first Linux machine. So node exporter will export all the OS level metrics such as RAM, disk space, and CPU utilization and sizing and all that. It will export all those information, and Prometheus will capture that information. And further, Prometheus will connect to Grafana, and it will showcase all those information in form of graphs and charts. So this is what we are going to set up now. Okay. Now we don't need this. Okay. Let me close this one. Just a second. Okay, now first I will take you to my JMeter, to the AWS instance. Now we don't need this. Let me close this one. Okay, now this is my AWS EC2 dashboard. So as you can see over here, I have two Linux machines. First is Linux EC2 and second is the Prometheus server. Okay, now let's first start this Linux EC2 machine. So let me connect. Okay, so it is establishing the connection. Okay, now I am inside the first Linux machine. Now in this Linux machine, what I'm running is I'm running a web server. Okay, so let me check the status of that web server. Okay, so my web server is running properly. And the other thing I'm running over here is the node exporter. Okay, so let me check the status of the node exporter. So node exporter is also running at the port number 9100. You can check it on the bottom right corner. Okay, so this machine, I'm repeating again, this machine is running a web server on which my local JMeter will generate the load. this node exporter will expose all the OS level statistics, which will be captured by Prometheus server, which is running in my second Linux machine. Okay, so it's time to initiate the second Linux machine. So this is the Prometheus server. Let me connect. Okay, so I'm inside the second Linux machine and this is the Prometheus server. So let's check the status of the Prometheus server. Okay. As you can see that Prometheus server is running here on 9090 port. Okay. Now we need to connect this particular Prometheus server to our first machine where the node exporter is exposing all the data. Okay. So for that, what we need to do is we need to okay, this is keep on bugging me. Okay, so there is a file called prometheus.yml file. Okay, so this is the file in which you are going to configure that particular connection. So it is going to scrap the information from this target. Now this is the IP 54202. Just a second. Okay, so this is the IP of my first instance 54202.95.26 and its port number is 9100. Okay, so this is the target that I have given in my Prometheus server. So Prometheus server will capture all the data that is exposed by the node exporter. Okay, so let me okay, now Prometheus server is running, my node exporter is running, my web server is up and running. Now, what we need to do is we need to configure the Grafana dashboard in my local machine, right? So I am running Grafana in my local machine in the port of 3000. So localhost 3000. So this is the
Excuse me,
Grafana.
sir.
Yes.
Really sorry to interrupt, but we just have a couple of minutes left. Let's go ahead.
Yeah. I'll try to wrap up as soon as possible. Yeah. Okay, so this is the Grafana dashboard. Okay, now let's not talk about how we can do the configuration, but let me explain it in very brief. That first, what you need to do is you need to tell your Grafana from where you are going to read this all the data. So for that, you need to add the data source over here. So I have added two data sources. One is Prometheus and one is InfluxDB. So the Prometheus data source is coming from my EC2 machine and InfluxDB data source is coming from the InfluxDB server that is running in my local machine. So this is the InfluxDB server that is running in my local machine. And I have added these two data sources. And here I have added two dashboards over here. The first one is the Prometheus dashboard and second one is Apache JMeter dashboard. So this dashboard will show all the data, real-time data, whatever it is going to capture. Okay, so this is the Apache JMeter dashboard and this is the Prometheus dashboard. Okay, now we need to now what I will do is I will go to JMeter. I have configured a simple script. I'm sending one HTTP request to my first Linux instance. I am hitting that Linux instance. I'm keeping the thread count as 50 and loop count as infinite. So all 50 users will keep on hitting my first Linux machine. Okay, now let's start the execution. Okay, so as you can see in this JMeter dashboard, you can see that total number of requests are more than 3,000 now. Okay, error rate is at 0%. Total throughput, it is increasing. Active threads are 50 active threads that we are generating. Now keep in mind that this data is coming from InfluxDB, and that InfluxDB is connected with my JMeter. Okay, so the transaction response time and all that network traffic it is capturing. Okay, so all this data is capturing. Now if we check the Prometheus dashboard, now this is the Prometheus dashboard. You can see the current CPU of my first Linux instance is increasing. It is at 5%. The memory, the RAM is 33% of the RAM is utilized. Memory status is over here. Disk space is, it has 20%. And all these statistics that you are seeing over here. Now, this is the real-time data. This is the execution going on right now. And I'm able to verify all this data real time. Okay, so now let me go ahead to JMeter and stop the execution. You will see that the CPU will okay, now you can see that CPU was above 5%. Now it is decreasing because the load on the server is stopped. Now if I refresh it, now it is decreasing. So these are the statistics you can configure, and you can verify real time. So this is how the complete performance testing framework looks like. Now let me bring my slide. Okay, now this is the framework. Now along with these things, what extra you can do is, yes.
Sorry to interrupt. Will we be able to complete in the next 2 minutes?
Less than 2 minutes. Yeah.
Perfect.
Yeah. Okay. Yeah. Okay. So this is the last slide I'm having. Okay. So now this is the frameworks. Along with what we just discussed, you can trigger your JMeter scripts from Jenkins server. You can have your all the data on some repository like Bitbucket. You can have your own Apache JMeter farm where you can have multiple machines from which you generate the load, right? So in the distributed setup, you can have that, and you can have this complete JMeter framework at your disposal. Okay, so this is what the JMeter framework is. And next, okay, so I think I'm done from my side. These are some of the reference link that I will push it in the meeting chat. Now I'm open for questions.
Rishil, since we are already on time, like we wanted to have 5 minutes for question, maybe we can just quickly take only one question out of all the questions, and then we can move to the main event.
Okay, perfect. Okay.
Right.
Okay, so there is one question from Rameshwar. Is it node exporter AWS service? No, it is not an AWS service. Node exporter is the exporter provided by Prometheus. So you need to install it separately, and that is the node exporter. I will put the link of Prometheus, all the node exporters. So let's say if you want to collect the statistics from MySQL, so for MySQL, there is a separate node exporter available in Prometheus. So I will put the link over here. So yeah, I guess, yeah, we have limited time. There is so much more to discuss. Yeah, but I'm giving my email address over here. You can connect with me, and I would like to answer all your questions.
In fact, the second part, the entire integration with Grafana and the Grafana dashboard was really awesome.
Yes.
And that's my personal feedback. And I was really amazed to see that dashboard.
Yeah.
With the entire integration being done from the EC2 instance and the InfluxDB. Really awesome presentation.
Okay. Thank you so much. Thank you so much. That's it from my side. And yeah, if you have any questions, you can send it in the WhatsApp group. And
Yes,
yeah,
yes,
thank you so much,
definitely.
everyone. Bye-bye.
Thanks, Rishil. We will then